Hello, welcome to today's video. Let's look at how to solve some questions relating to equations, inequalities, and graph. This is Add Math for 10th graders or year 10 or grade 10, whichever suits you best. So we're going to solve equations involving modulus, that is absolute values, and also maybe look at how to sketch some cubic graphs. So let's get started. So the very first question, we've got 5 multiplying modulus of 5x minus 7 minus 1 equals to 14. The first thing to do is to try to isolate the modulus. So let me move the negative 1 to the side. So I've got 5x minus 7 in modulus is equal to, the negative 1 moves there, and I'll get this to be positive 15. Another thing to do to isolate the modulus even further will be dividing everything by 5. This then gives you modulus of 5x minus 7 is equal to 3. Now, to take off the modulus, there are two ways to go about it. Either you square both sides or you introduce plus or minus. Since modulus of negative 3 is equal to 3 and modulus of negative 7 is equal to 7, also modulus of 7 is also equal to 7. So if I give you modulus of x to be equal to 9, it could be that x is equal to either positive 9 or x equals to negative 9. So we've got every right to take off the modulus by introducing plus or minus. So that expression you see, 5x minus 7 is equal to positive 3, and at the same time 5x minus 7 can be equal to a negative 3. So we solve this equation, move the 7 to the other side, you get 5x equal to 10, then x is equal to 2 by dividing everything by 5. Then we do the same thing, we add 7 to both sides of the equation, you get 5x to be equal to negative 3 plus 7, which is going to be a 4. Then divide everything by 5. Then x is equal to 4 over 5. So that will be the first one. The second one, you have to sketch the graph of y is equal to modulus of 5x minus 3 on the axis below, showing the coordinates of the points where the graph, showing the coordinates of the points where the graph meets the coordinate axis. Okay. This is a cool question. There are two ways again to sketch this one. Either we sketch this equation of the line y equals to 5x minus 3, then we reflect the part that is below the x-axis above the x-axis, or we go through another method of solving. I don't like the method of reflecting, so let's go through another method. So with this one, we first need to find the turning point, and we need to find the y-intercept. So for you to find the turning point of a modulus function, one main thing you have to consider is the fact that the coefficient of x should be 1. So in this case, the coefficient of x is 5, so we can do something to it. This will give you modulus of, we can factor out 5, so let me just write 5x minus 3. So this will give you modulus of 5 out, then x minus 3 over 5. Now that we've written this in this form, we can get our turning point. Just like quadratic equations, if you've got a quadratic function written in the, is it a standard? Not really a standard form, like a completing of squares form, where you've got x minus 3 all squared plus 7. The turning point of this is going to be the negative of this, so there's going to be 3, 7. Therefore, the turning point for this one is going to be 3 over 5. And this can be written as plus 0, so 3 over 5, 0. So that's the turning point. So let me say that this is my 3 over 5, 0. 3 over 5, 0. And the next thing is to consider the symmetry nature of the curve. What I mean by that is, because it is going to look like a V-shaped curve, the distance between any 2 points should basically be the same. So if this is 3 over 5, the next distance I'm going to look out for is going to be positive 6 over 5. So this is 6 over 5. You know why very soon. The y-intercept, for y-intercept, we say that x is equal to 0. So wherever you see x, you put 0 over there, and this will give you y is equal to modulus of 5 of 0, which is 0 of course, minus 3. Modulus of negative 3 is going to be a positive 3. So there's going to be a y-intercept that's positive 3. Let's assume that is our y-intercept, which is positive 3. Don't forget, you need to indicate all. The question said you should indicate all of them. So there's a turning point, and the 6 over 5 would always correspond to the y-intercept. That will consider the symmetry nature of the curve. So this goes this way. So there's one method of sketching the modulus graph, and I'll stick to this method instead. Let's see if there are more questions to answer. Yeah, question number 2b. You have to solve this equation. Again, there are two ways to solve this one. Either you introduce a plus or minus, or you square both sides. Because I introduced plus or minus in the previous one, let me just square both sides for this one so that we answer the question. Squaring both sides will give you 5x minus 3 all squared is equal to 2 minus x all squared. Squaring of this will be 25x squared. 5 times negative 3 is negative 15, so negative 15 times 2 is negative 30x. Then negative 3 squared is a positive 9 is equal to, I do the same thing over here, 2 squared is 4, 2 times negative 1 is negative 2, times 2 is negative 4x, then negative x squared will be a positive x squared. And now rearrange everything, that will give you 25 minus x squared. Moving this x squared to the side of the equation, it should be negative 25x squared minus x squared should give you 24x squared. Now negative 4 moving to the side of the equation will be a positive 4. So negative 30 plus 4 is going to be a negative 26. If my math is correct. So 26. Then 9 minus 4 should be 5. So plus 5 is equal to 0. Let's use a calculator to solve this one and see what we get. So a polynomial of degree of 2. So we've got 24, negative 26, positive 5, and the answer is 5 over 6 and 1 over 4. So 5 over 6, 5x minus 6, then 4x minus 1, we go to 0. So this gives you x equals to 5 over 6, then x equals to 1 over 4. Or another method to use will be introducing the plus or minus. That is my favorite method, by the way. So this 5x minus 3 is equal to 2 minus x, or we say that 5x minus 3 is equal to negative 2 plus x. So this will give you 6x if you move this negative x across the equal to sign. Now 6x, and you move this 2 over there, that will be positive 5. So 5, divide everything by 6, divide everything by 6, x is equal to 5 over 6. Just like we got with this one, 5 over 6. Then do the negative aspect, which will be move this x to the side, it becomes negative, so that gives you negative 4. Move this negative 3 over there, it becomes positive, so positive 1. Divide everything by 4, divide everything by 4, x equals to 1 over 4. So whichever method you feel comfortable with, I would advise you go with it. Yeah, question number 3. We're given a diagram and we have to find the function that generates this curve. Quite an interesting question. So as you learned in class, we basically have to start with the x-intercept, then we work our way around. So in this question, we can say that p of x is going to be equal to x plus 2. The opposite of this number is negative 2. Negative 2, the opposite is going to be positive 2. So the next one is going to be x plus 1. The next one is going to be x minus 4. Well, this would have been correct if we don't consider the y-intercept, but we have to consider the y-intercept, because if you have to find the y-intercept over here, there's going to be 2 times 1 times 4, which is negative 8, and it's not equal to 24. So there is something wrong. There should be a value over here. I think you can guess from here, because if we multiply this one and we're getting 20, we are getting 8 and we are looking for 24. This must be 3. But anyway, let's put a variable over here. Let's say k. So we're now going to consider the y-intercept. So for y-intercept, x equals to 0. So for y-intercept, x equals to 0. This then gives you k into brackets 2, 1, and negative 4. This is equal to the y-intercept over there, which is 24. Then this gives you negative 8k is equal to 24. Then k is equal to 24 divided by negative 8, which is going to be negative 3. So we can say that one of the function will be p of x is equal to negative 3, x plus 2, x plus 1, and x minus 4. But because this is a modulus cubic graph, the answer can be 2, either the positive side or the negative side. So we say that the other answer is going to be the positive form of this. So instead of negative 3, there's positive 3. You can use this one as a guide. We're told to find the two possible expressions for p of x. So these are the two possible expressions. One is for negative and one is for the positive. So that answers this question as well. Not so complicated. I think a similar question over here. This one is not the modulus version of it. So let's see how to work this one around. Again, we start with the x-intercept. Always start with the x-intercept. It's very important. So the opposite of the number is going to be x plus 2. The opposite of that number is going to be x plus 1. Then the opposite of that number is going to be x minus 5. Then we introduce our constant k. We then look out for the y-intercept. So for y-intercept, we say that x equals to 0. This then gives you y is equal to, or let's just put our 0 over there. So k, 0 plus 2 is 2, 0 plus 1 is 1, and 0 minus 5 is negative 5. This equals to the y-intercept. In this case, the y-intercept is 5. So let's do some vector simplification. This will be negative 10, k is equal to 5, then k should be equal to negative 1 over 2. Therefore, our function will be f of x is equal to negative 1 over 2, then x plus 2, x plus 1, and x minus 5, and that will answer this question. And that wasn't that difficult. This one we accepting the negative and not bringing the positive because there is not a modulus curve, it's just a regular curve, so we don't need the positive and negative aspect of it. Now the next question says that find the range of values for which f of x is greater than 0. Greater than 0 is talking about the portion of the graph which is above the x-axis. So looking at this side, you can see that it's above the x-axis, and looking from this side all the way to this side is also above the x-axis. So we say that the range of values will be x is less than or equal to negative 2, and at the same time x is in between negative 1 and positive 5, negative 1 and positive 5, and that answers this question. Not too much of a big deal, so you have to be very careful about the signs, not to interchange them. So numbers to the left of negative 2 are all less than negative 2. Numbers from negative 1 to 5, this is how to represent them. The numbers will be greater than, their number is greater than negative 1, but at the same time that number is less than 5. So in short, you can say that x is in between negative 1 and positive 5. The next question, this time you have to draw the modulus graph. So on the axis below, sketch the graph of y is equal to modulus of x minus 2, x plus 1, and x plus 2. So starting with the x-intercept to make things easier. So let's start with the x-intercept. So for x-intercept, y is equal to 0. We then equate each and every bracket pair to 0. This then gives you x minus 2 is equal to 0, x plus 1 equals to 0, then x plus 2 equals to 0. We solve for x in this case, x equals to 2, x equals to negative 1, and x equals to negative 2. So let's plot this one. Let's see if I can get something. This is not drawn to scale, by the way, so don't beat me in the comment section. And let's say this is 2. So we also need to know the orientation of the curve. Because this is modulus, it doesn't really matter, so it's going to be one way. But let's just assume that we're drawing the normal curve. If it's a positive curve, it's going to look like this. And let's find the y-intercept. For y-intercept, we say that x equals to 0. So this gives you y is equal to modulus of negative 2, because 0 minus 2 is negative 2, then 1, then 2. If I do this simplification, negative 2 times 1 times 2 will give you negative 4. Inside the modulus will give you 4. So we know that there is a y-intercept at 4. At this stage, we are not really going to use a turning point to do the sketching, so we are good for now. When we start calculus, we may use the turning point to do the sketching. So let's assume that this may not be accurate because I'm not using the turning points. Let me just clean this portion, it's not looking nice. Okay, so don't worry, let's assume that it's touching it. Let me move this technology bit. So this is what we should be expecting for the answer to the question. At least we are showing the vitals, that is the y-intercept and the x-intercept, and also the look of the modulus cubic curve. Okay, so that is the fifth question. And the sixth question, this is quite an interesting question. You have to be very careful about this negative because it's going to determine a lot of things in the question. For starters, it's going to determine the orientation of the curve. Question number 6 says that on the axis below, sketch a graph of y equals negative brackets open, x plus 2 brackets closed, x minus 1, and x minus 6, showing the coordinates of the points where the graph meets the coordinate axis. Basically, you have to find the x and y intercepts. As simple as that. We first need to know the orientation of this curve. We need to determine whether it's going to be this way or it's going to be this way, because it's going to determine how we do the sketch. So this way and this way. Once we can get the orientation, we are good to go. There is a positive orientation because it's pointing towards a positive y-axis, and there's a negative cubic curve because it's pointing towards the negative y-axis. So let's find the x-intercept. Always start with the x-intercept. This is the easiest thing you can ever come across. So x plus 2 is equal to 0. Then x minus 1 equal to 0. Then x minus 6 equal to 0. So the x-intercept will be x equals to negative 2, x equals to 1, and x equals to 6. Again, my drawing will not be drawn to scale, so let's assume that there's 1 and there's 6. And let's assume that there's negative 2. For y-intercept, we didn't determine the orientation of the curve. To determine the orientation of the curve, you would have to multiply the x's. So there's x times x times x. Don't forget that there is a negative outside too. So this becomes negative x cubed. So x times x times x times negative 1 will give you a negative x cubed. So we're going to look at the shape of the curve. We don't really know the turning point. Again, we are not using turning point as at this stage. So this is how the graph is going to look like. Let's find the y-intercept real quick. So for y-intercept x equals to 0, let me clear this one. So for y-intercept x equals to 0, x equals to 0. So this gives you y is equal to negative brackets open, 0 plus 2 gives you 2, 0 minus 1 gives you negative 1, 0 minus 6 gives you negative 6. Then this gives you negative 1 times negative 6 is a positive 6, times 2 is a positive 12, times negative is a negative 12. So we know that our y-intercept is at negative 12. So let's just get our curve drawn. Again, there's not going to be accurate. Don't worry, I'll move it because I'm using a detail tool. I can easily move it. Okay, so there's where my negative 2 is, and there's my negative 12. And and there's where my 6 is. So your curve should basically look like this. It's not a perfect curve, but this was the examiner should see the key points, the x-intercepts. We should see all the x-intercepts over there. We should see the negative 12 being the y-intercept. So that's the 6th question. I think probably the last question. Let's try to do this under 20 minutes. Yes, this question too can be solved using the plus or minus or squaring both sides. Let me use plus or minus since it's the easier one. So we can take off the modulus and introduce plus or minus. 5x plus 3 is equal to plus and minus 1 minus 3x. We can then split this into two different equations. So 5x plus 3 is equal to 1 minus 3x, or 5x plus 3 is equal to negative 1 plus 3x. So I just multiply through with the negative and you get negative 1 plus 3x. We now move this negative 3 to the other side of the equation, which is going to be a positive 3. 5x plus 3x, 5x plus 3x in this case is going to give us 8x is equal to, now we move the positive 3 to the other side of the equation, that will be negative 3, so 1 minus 3 will be a negative 2. We can now divide by 8, then x is equal to negative 1 over 4. That answers this part of the question. The next one is going to be move the 3x across the equal to sign, that was going to be negative 3x. 5x minus 3x will give you a 2x. Then move the positive 3 across the equal to sign, that is negative 3. Negative 3 minus 1 is going to give you negative 4. So divide everything by 2, then x is equal to negative 2. That will answer this part of the question as well. And the last part of this is one of the few cases I would advise not to use the plus or minus. And if you want to use a plus or minus, make sure that you set up the inequality wall. So to use a plus or minus, what I normally tell is repeat the symbol you see exactly how you see it. So this symbol is a greater than if you are reading from left to right. So repeat it 2 times, then you put the 1 in modulus in the middle. This becomes the positive aspect and this becomes the negative aspect. But like I said, I won't advise this method for inequalities. I would advise you to square both sides. That would be better. So I'm going to use that method instead of this method. So squaring both sides of this is going to give you 3x minus 1 all squared is greater than 3 plus x all squared. If you square this one, that should give you 9x squared. Take your time and square it. 3 times negative 1 is negative 3 times 2 is negative 6x, and negative 1 squared is a positive 1. This is greater than 3 squared is 9, 3 times x is 3x times 2 is 6x, then x squared is x squared. Move everything to one side of the equation, move the x squared to the other side of the equation, that becomes negative x squared. So 9x squared minus x squared should give you 8x squared. We can now move the negative 6 across the equal to sign as well. Sorry, positive 6 across the equal to sign, which becomes negative 6. So negative 6 minus 6 x should give you a negative 12x. Then finally you can move the 9 across the equal to sign. Then 1 minus 9 is negative 8. This is greater than 0. I'm not really going to waste my time to solve this one. Let's just call on the calculator. This a class-based calculator. I would advise you use this calculator instead of the regular normal Casio calculators. At least this has got a function for quadratic inequalities. So the quadratic inequality we are solving is the greater than symbol. So let's look out for the greater than, which is the first one, ax squared plus bx plus c is greater than 1. So the first one. Then we input our values. So we got 8, negative 12, and negative 8. So we get the answer to be x is less than negative 1 over 2 and x is greater than 2. So x is less than negative 1 over 2 and x is greater than 2. And that answers the question for this for 3 marks. Okay, so that's who answered this one. The next one, we've got solve the equation 2x raised to the power 2 over 3 minus x raised to the power 1 over 3 minus 10 equals to 0. So what we can do to this one is to make one of the variables look exactly like the other variable without breaking any rule in math. So it's that simple. So what I can do over here is with the x raised to the power 2 over 3 from indices, x raised to the power 2 over 3, this is the same as writing x raised to the power 1 over 3 all multiplied by 2, like a power of a power. The rule that says that m raised to the power n or raised to the power n is equal to m raised to the power mn. So you can rework on your indices and the regular math. This is where you're going to apply your regular math to the additional mathematics. So this equation can be rewritten as 2 brackets open x raised to the power 1 over 3 all raised to the power 2 minus x raised to the power 1 over 3 minus 10 equals to 0. So let's m for math file, let m be x raised to the power 1 over 3. If that's the case, then this will give you 2m squared minus m minus 10 equals to 0. So again, there's a quadratic equation. We can solve this quadratic equation. So polynomial of degree 2, we've got 2, negative 1, and negative 10. That should give you m to be equal to 5 over 2. So we can say that 2m minus 5, then m plus 2 equals to 0. So m equals to 5 over 2. Let me write my 5 over 2 and m equals to negative 2. At this point, we didn't start the question with m, we started the question with x. That's what we are finding. So we can do back substitution. So wherever you see m, we put x raised to the power 1 over 3. So we got x raised to the power 1 over 3 is equal to 5 over 2. Then at the same time, x raised to the power 1 over 3 is equal to negative 2. I can cube both sides to get rid of the fraction at the exponent. So x raised to the power 1 over 3 cubed will give you x. Then 5 over 2 cubed, that should give you 125 over 8. 125 over 8. Similarly, this will give you x, and negative 2 cubed will give you negative 8. And that will answer this question. So we are 24 minutes into the video. Let's see if we can make the 30 minutes. We do this less than 30 minutes. Question number 8. And I think this is the last question. On the axis below, sketch a graph of y equal to 2x minus 3. So again, there are several ways of sketching this one, but my favorite method is just to find the turning point and the y-intercept. So in this case, the turning point, we need to factor out 2 to make sure x stands alone. So 2 comes out, and this gives you x minus 3 over 2. Then the turning point for this one is going to be 3 over 2, 0, which is 1.5. It should be somewhere here. Then the y-intercept. For y-intercept, x equals to 0. So wherever you see x, you put 0 over there. Y is equal to negative modulus of negative 3, which is going to be equal to 3. Because if this is 0, you get 0 minus 3, which is negative 3. So let's indicate our 3. This is our 3. Then we draw our first line to pass through this 2. And don't forget to consider the symmetry nature of the curve. So if this is 1.5, then the next point will be at 3. And that will also correspond to the y-intercept. So in this case, this is going to be here, considering the symmetry nature of the curve. And that will be the drawing. And we are good to go for this question. So not that difficult for 2 marks. And I think this is the last question. We've done our best. We've solved all the questions in less than 30 minutes. So with this question, I would advise again to isolate the modulus and work with it. So let me move the modulus to the other side of the equation because it's negative, so that becomes positive. This then gives you 7 is equal to modulus of 2x minus 3. From here, we can take off the modulus by introducing plus or minus. So plus or minus 7 is equal to modulus of 2x. Take off the modulus, 2x minus 3. Then this gives you 7 is equal to 2x minus 3. Or negative 7 equal to 2x minus 3. Move the negative 3 to the other side of the equation. That becomes positive 3. So 7 plus 3 is 10 is equal to 2x. Then also we can add 3 to both sides of the equation, or we can say move negative 3 to the other side, which becomes plus 3. Negative 7 plus 3 will be a negative 4 is equal to 2x. We can then divide everything by 2. Divide this one by 2. This will give you x to be equal to 5. And this will give you, divide both sides by 2. And x is equal to negative 2. With all the questions you've solved, it's advisable to check if your answers are correct. You can do that by substituting back the answers into the original equation, and that will be a way to just check whether you are right or wrong. At times, some answers you may get may not be necessarily answers to the question, so it's advisable to check if they are all answers to the question. And we did this in less than 30 minutes, and that will be all for this video session. 8 questions down. Bye bye for now.